Hi, this is Lori and welcome to my series on the Pico W. In this multi-part series, we're going to be exploring LED displays. And we'll start off in this part with the 7 segments. But first, let me tell you a little bit about what I have planned for this series. Well, you may have noticed that I haven't had a lot of content on my channel since the beginning of the year. And that's because I had to have my knee replaced in February. So that kind of got in the way of being able to spend any time sitting at a workbench and working on things for any length of time. So I took a little bit of a break, but as I was doing that, I started kind of digging through some of the beginning electronics kits that I've purchased over the last couple years for Paul McWhorter's Arduino and for his Pico W class. And I noticed that there were some components in there that Paul never seems to have utilized in any of his courses, at least as I remember. And that was the LED displays that are usually included. So over here we have a 7-segment display, an 8x8 matrix, a bar graph, and a 4-digit 7-segment that I've had in some of my kits. And I thought it'd be fun to just get started with those and learn how to set them up and how to control them. And it might be a nice way to get back into doing electronics again. And as I was learning how to put these together, I realized there's some other interesting companion components, modules that are also useful to know about, to use these LED displays. And so we'll talk a little bit about these as well during this series. So breadboard power modules, dip switches, network resistors, and shift registers. And you can use the 595 to increase the number of outputs you have on your microcontroller, and you can use the 165 to increase the number of inputs you have. And so I thought they were interesting to work through, and it can be a little complicated. There's certainly a lot of good videos out there on them, so and maybe my understanding of them might not be 100%, but I'll share with you what I learned as I learned how to use them to control some of these LED displays. It's nice to learn how to use these LED displays without any specialized libraries or driver chips that make it much easier to use them. But in the end, you're probably going to use these displays with some sort of driver chip. And after I finished going through all of the basic LED displays and kind of working them through my own code and maybe some shift registers, I turned my attention to LED displays that have modules or driver chips attached to the module and make it easy to use. And you can get a MicroPython library to help you manage the display. So I have a couple sets of LED matrices that use the MAX7219 chip. Here you can see these are pretty common. A lot of people pick them up on AliExpress or Amazon, relatively cheap. You can see they can be chained together or as individuals. And then I picked up some LED displays over the last couple of years from Adafruit. So this one here, the 8x8 bicolor LED matrix, it has 2 LEDs inside of each cell, so it has a red and a green, and so you can have red, green, off, and then when you turn both the red and green on, you get kind of an orangey color. So that's a lot of fun. I've already made a episode on this a couple of Christmases ago. It's a fun matrix to play around with, so we may come back to that and do a little bit more with it. But we'll definitely work with these two. I picked up a 4-digit 7-segment using that same driver chip that the bicolor has. And then I got a 4-character 14-segment display as well that uses the same driver chip. And this one would allow us to have letters displayed. We could do W's and M's, for example, with this kind of a display where we can't really do those with the 7-segment. So in total, there'll be between 8, maybe 9 episodes in this LED display series as I went through and learned how to use each of these. And I'm no expert at this. This is just what I learned as I went along. I definitely spent some time learning how to use persistence of vision to control the LED displays so you don't have to use as many resistors and GPIO pins, for example. And a lot of that's taken care of for you, when you get these displays with driver chips and get a library. All that's been done behind the scenes by the library author. So I do a little bit of that kind of work without having the driver chips, but in the end, this is probably how you're really going to do things. So I'll devote a few episodes to using these and managing them as well. Well, I hope you'll enjoy the series, but now let's get on to the 7-segment. Well, a 7-segment display with a decimal point means it actually has 8 segments, but they don't count the decimal point for some reason. So you probably have one of these in your in a beginning electronics kit. You can see this is how it comes, all the pins. It's not no driver chip or anything on it. And there are 2 kinds. So there's one that would be a common cathode, and in that one we would connect these pins here, 3, the ones that are marked COM for common. We would connect those to ground to use it. And a common anode, we would connect the common pins to power. So it's kind of just like an RGB LED. They can be the same thing, common cathode and common anode, except for now we have 8 LEDs inside of here that we can control. And you can see here on the pinout, it tells us, which pin actually controls which LED, which segment of this display. And it's not in any kind of particular order. It seems, I think it's whatever was convenient for routing it inside of here. So we have 8 LEDs that we can control and connect up to pins on our Pico. Well, your next question is whether you have a common anode or a common cathode 7-segment. You can determine that using the continuity setting on a multimeter. I just find it a little hard to hold on to all those pieces at the same time to figure that out. Or you can set up something like what I have here on a breadboard. And I'm using a breadboard power module to bring power and ground to the breadboard. And turned out in my kits I had both kinds. I had mostly cathodes, but I did have some anode as well. And here you can kind of see, it may not show up quite as well, but the common anode I have connected to the power here on the common pin. And for the cathode, I have it connected to ground, that common pin. You notice I didn't have to have it connected on both sides. Just pick one of the common pins or the other, whatever's convenient. And then I'm using a breadboard power module to bring power and ground to the breadboard. And I'm using one that it can be powered this way with one of these jacks, and also has a USB type jack that you could bring the power. And these breadboards allow you to put 5 volts or 3 volts on the rails. Some of them allow you to select what you're sending out, 3 or 5. And some of them it's one side or the other. I have a couple others in my lab, just checking to make sure I'm showing that. So this is one I got in a kit, and you can see the different ways I could power it. And these little jumper things are how you decide whether you're going to put 3 or 5 volts on the rail. So with these kind, you can choose to have 3 on one side and 5 on another, for example. It's pretty handy. Here's another one that actually has a built-in battery that I got from a Sunfounder kit. And same thing, USB type connectors to bring power into it. And yeah, we can turn this one on and off. It's a nice, maybe a little nicer one, a little more going on for it. But it was a little more expensive, I would guess. And I also picked up, I think I got this at Adafruit. I have a little power. This is how I bring the power in, and I can select, you can see here, I can select the voltage I want. So that's a nice little handy thing to have around as well. So I'll plug that in. And I know that this is an anode and this is a cathode, but I did have to experiment. Sometimes you can tell by the writing on the side. It turned out in the writing on the side of these things, if it had an A, it was a common cathode. If it had a B in this number, it was a common anode. But I certainly didn't know that going into it. Make sure I got it back in the right spot. So I have the common pin for the anode connected to positive. So then if I connect into any of the pins with ground, then I'm going to light that LED for that pin. And you can see as you move around, you will light different parts of the segment. So that one's an anode. Now if I look at the cathode one, because I have it plugged into ground rail here, then I'm going to give it power to try to light one of them as well. You can see this is not a great breadboard. But yeah, so I can light, this is the decimal point right there. So I can light them, and I know that this is a common cathode. So I found that an easy way to figure it out, and yeah, fun little setup to use, and allowed me to play around with some of my breadboard power modules. Here's the first circuit we'll set up for our 7-segment display. And it's a lot of wiring because you have 8 LEDs in here, and you're going to need 8 GPIO pins to control them individually. And you might see in some videos where people only use one resistor on the common pin to be the current limiting resistor for the LEDs. And that doesn't work well if you're lighting all the LEDs simultaneously. So if you have an 8 with just a single resistor here versus a 1, you're going to see a difference in brightness because you're using one resistor for 8 LEDs at a time. So I guess the potential to burn them out might happen as well. So I took the time to wire this up so that each LED has its own current limiting resistor, and that means we can turn them on simultaneously. We can have an 8 versus a 1, and we're going to get the same brightness, and we're not going to have a potential to burn our 7-segment display out. We'll talk about other strategies for not having to have all these resistors, but if you want to, I guess, do it the right way, I think you really need these current limiting resistors in here. If you're going to turn on the LEDs simultaneously, it's a better setup. But it's a lot of wiring, so you can see why people like those driver chips, because it handles a lot of this work for you. Okay, we have the actual circuit here, and you can see I took the time to make my own connections rather than using jumper wires. I tried that initially, and it just wasn't reliable. Something would come undone, and pretty frustrating. So when you hook up something this complicated, making your own connection wires is probably the way to go. So that's all good, and you can see I have a common cathode connection here on my 7-segment display. And now this is going to be what I call a beginner code. Very simple code. I will use some fancy print statements, but they're not necessary for the operation, so you can leave them out if they're complicated. But we need to set up all the LEDs, each on its own pin as outputs. I have a couple variables just to control the timing as each segment is turned on. So we're going to turn them on top to bottom, and we'll start with A, turn it on, and I'm going to print that to the shell that I turned on A, and I'm using end equals quote /R. That just is going to replace the line instead of kind of scrolling as we go. We'll sleep the short delay, that's how long it'll be on by itself, and then we'll go to the next one. We'll turn on F, and then B and G and so forth until we have them all turned on, all the way down to the decimal point. Then we'll take that longer delay, and then we'll start turning them off from bottom to top. So we'll turn off the decimal point and go through all the other segments, and we'll just keep looping till we stop the program. Let's let it go. All right, seems to be filming okay, and it's brighter in person than it is here, but you can see it going on. And now we're going to go off. Yeah, so that's our first simple program. And now we're going to make it a little more complex because, as you can see, when you're doing something like this, it'd be better to use a loop Instead of explicitly writing each of these out, we can make our code simpler to follow. All right, here's our beginner code, but using loops, and I'm also using try and except so we can cleanly exit this program. We'll set up everything just as we did before, but we're going to create a couple of lists here. We'll have the segments in the top-down order, and then we'll have the segments in the bottom-up order, so we can loop through them and turn them off in the order that we want to do that. So this is how we can control the order. And we'll have our delay times. And now in the try part, we'll have our while true loop, and we'll go through the segments top to bottom, turning them on and continuing through all the segments till we have them all on. We'll take that longer delay, and then we'll loop through the segments bottom up, and we'll turn them off one by one. And if we do a keyboard interrupt at any point, well, we'll loop through, doesn't matter which one of these is, we'll loop through the segments and we'll make sure they're all turned off so that we don't leave any stray ones on. So I kind of like this code. And you can see I got it going a little faster this time. And if I Control C, it'll stop and turn off. And I didn't have the print on there anymore since we saw how that worked in the first one. Well, this will be our last program for this episode. It's already getting a little long. Well, in this code, we're going to have the LED appear to be racing around as we turn it on and off the figure 8. And all we have to do is figure out the path we want the lighted LED to follow, in what order. And then we'll have it move pretty quickly so it looks like it's racing. And we'll just loop through that list, turning on and off that segment. And we'll use the try and except so that we can cleanly exit the program. So let's let it run. There we go. Yeah, looks good. I think you could come up with some other interesting patterns to put on a 7-segment display. That might be a fun thing to do. In the next episode, we'll actually put the numbers on 0 through 9, and we'll count up and down and learn a little bit more about how to control the 7-segment display when we're actually trying to put some numbers on the screen. But with that, I want to thank you for watching.